Good afternoon, everyone. Hope you're having a great day as we aim to finish this first lesson as we discuss systems of linear equations. Yesterday we learned that depending on the system, there could be one solution, there could be no solutions if there are parallel lines, or if they're the same line, just written in different forms, or in different form, there could be infinitely many solutions. So what we're going to do today is we're actually going to work on solving some systems using graphing. I had mentioned in the comments above that using graph paper is really essential when we solve systems of equations using graphs. You'll soon hear me say, not just right now, but in later lessons, that using graphs isn't the most efficient way, but is definitely one of the best ways to kind of just see what does the graph look like. The reason that it's maybe not as accurate or the best method is because if you use a different kind of scale, you don't know if the answer is a decimal, or if you're counting by fives and you have 5, 10, 15, and 20. Well, it's going to be pretty hard to distinguish between 21 and like 23 if that was like part of your solution. So today we will just kind of work on solving these. Shouldn't be too difficult. Let's go ahead and jump right in. So we left off with example 1 yesterday, so here we are going to do example 2. Okay. Example 2. Graph each system. And remember, yesterday in the example, we graphed them, whereas in the homework you were just given the graphs. Graph each system. Determine how many solutions and then if there is one, then if there is one, then give the solution. Now, one big thing to remember here is that the solution to a system is where the lines cross. Okay, so that's what we're always going to be finding as we work on solving these systems. Whether we use a graph, whether we use in lesson 2 and 3 and 4, we'll learn kind of the different algebraic ways we can solve these, which is at the end of the day going to be the best way to solve these. But really seeing this visually should help us understand those later concepts. So that's why we do this now. So our first one is going to be rather straightforward. It is going to be, I've got 2x plus 4 equals, sorry, I should probably write y equals first. So there's the brace. Y equals 2x plus 4, so we should notice that that is slope-intercept form. And then we have negative x plus y equals 2. Okay, so we've got slope-intercept in standard form. So let's go ahead and graph this. That will always be that first step in these problems. Okay, and I'm just going to go by ones. I think that is going to be the best way to do this. So let's go ahead and graph that first one. 2x plus 4. That's going to be a y-intercept of 4. 1, 2, 3, 4. and then a slope of 2. So I'm going to go down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. I'll take my ruler, connect those dots. So you should see, just even here on the get-go, and even from yesterday, why graph paper is so important when we solve these by graphing. Now, let's take a look at negative x plus y equals 2. Now, because this is in standard form, we use the cover-up method to find the intercepts. So when x is 0, the y-intercept is going to be 2. And then when we cover up y, the x-intercept is going to be negative 2, because we need to get that negative to the other side, so x equals negative 2. So it's right there. So there are my two intercepts. And take a look at this. Our lines do indeed cross one time. So there is one solution. Which means that this is a consistent system and they are dependent on one another to find the solution. And our solution here, the intersection, is at negative 2, 0. Okay. Now, one thing that you could do is you could plug these numbers in and check your answer. Even here, you could do it mentally. If we plug in a negative 2 here, 2 times negative 2 is negative 4. Negative 4 plus 4 is, surprise, it's 0. Also here, negative 2 will be positive 2. Positive 2 plus 0 is indeed 2. So we see that the solution definitely does indeed work. Let's do another one. Okay. So we're really always kind of looking for that slope-intercept form to graph, and then using those intercepts to graph the standard form of that line. Let's do another one. Y equals negative 2x minus 3 and 6x plus 3y equals negative 9. Okay. Let's go ahead and draw that first graph. We see that the y-intercept is down at negative 3 with a positive slope. So when we know that, we can kind of gauge where our graph is going to be. So negative 3, 1, 2, negative 3. Oh, that's a negative 2. Here, sorry, I actually need to change this y-axis a little bit. I need to push it this way. So negative 3. 1, 1, 2, negative 3, and our slope is negative 2. So up 2, left 1, up 2, left 1, up 2, left 1. And heck, we can go down 2, right 1. So here's going to be that first line. Okay. All right. Now, let's go ahead and graph 6x plus 3y equals negative 9. Let's use that cover-up method. So we cover up the y. So this is talking about the x-intercept. When y is 0, we do negative 9 divided by 6. That gives us negative 1/3. Yep, negative, no. Wait, yes. Well, negative 6 divided by negative 9 divided by 6 is, negative 1/2. Negative 1/2. So negative 1/2 is right about there. Uh-oh. Take a look at this. If we then cover up the x, the y is going to be negative 3, which is down there. These lines are the same. So there are infinite solutions. Okay? And if you want to get all fancy and write that infinity symbol, like that it's that sidewards 8, or an 8 on its side. Maybe that's a better way of saying it. Okay. Now, in our last example that we'll do today is we are going to do a story problem, because we don't always just want to stop at the algebraic. How would we be able to use this in the real world? Example 3. This one, like this one. This is a good one. One alligator that weighs 4 pounds gains 2 pounds every week. Another alligator gains 3 pounds every week and starts at it's 2 pounds. Starts at 2 pounds. When do they share the same weight? Okay. Oh, sorry about that. I'll move it down. All right. One alligator that weighs 4 pounds gains 2 pounds every week. Another alligator gains 3 pounds every week and starts at 2 pounds. And we want to find when do they share the same weight. And we'll even want to find what that weight is. Now, as we take a look at this, we should see that we are talking about the weight, or technically it would be the mass, of both of these alligators, because in the physics world, weight is actually a force, and mass is talking about how much something is. So you could say that the mass is 4 pounds and gains 2 pounds of mass every week. But this is math class, so we'll just throw that in for that's free. All right, so the first thing that we'll need to do is we need to find our system. Okay, our system. Now, the things that we need to remember is that when we see a rate, we should remember that a variable will always go beside that rate. So the fact that it says that this first alligator gains 2 pounds every week, that means we've got to have 2W. Okay? Because every week it gains 2 pounds. Now, it says that it starts at 4 pounds. How do you think we would represent that in this equation? Yeah, we're going to add 4 pounds because that's kind of like the starting point. It's kind of like the idea of like you have $100 in your bank account and you gain $10 every week. So that 100 would be kind of like that y-intercept. Our y-intercept here is going to be 4. Now, this equals the mass. I'm going to put mass because I don't want to use W since W is weak. That's the mass of that first alligator. Okay. Now, what I want you to do is, in the next 15 seconds or so, why don't you find out how do we find the mass of that second alligator? So here, our mass for that second alligator, it's got a different weight. It's gaining 3 pounds every week. So this will be 3W. But then it starts a little bit lower. So it'll be plus 2 because it's 2 pounds. Now, sometimes you might be given the equation for the system, or you're going to be asked to write it like we did here. Just remember that the rate in the problem is always going to be that slope that needs to go next to the variable. More often than not, you're going to be writing these equations in slope-intercept form. Okay, that's really important. That slope-intercept form, remembering that. So here's our system. Now let's graph. And at this point, we should be pros at graphing in slope-intercept form. Okay, so our x-axis is W for weeks, and our mass will be the y-axis. So let's go ahead and graph that first one. Our y-intercept is 4. 1, 2, 3, 4. And our slope is 2. Okay. Yeah, is 2. We actually need to change this scale so that we can... You know what? It's okay. It's alright. I see what the answer is. And we can do it on here. Okay. And then we'll just do 1, 2, 3. Spoiler, I know what the answer is. So, here we go. So we're going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Wow, we've just kind of cut into the story problem here. That's okay. That's all right. Now, one thing to notice here, in this real-world problem, as in every other real-world problem, you should be using just that positive x and positive y, that first quadrant. Okay? That first quadrant. So there's the mass of that first alligator as it goes up every week. Now, let's go ahead and do the second one, the second. So ours starts here at 2, and our slope is 3. 1, 2, 3, 1. Because remember, 1 going across on the x is 2. Then go up 1, 2, 1, 2, 3, 1. 1, 2, 3, 1. Aha! Take a look at this. If you saw that second to last point, we see that we do indeed have an intersection. We should recognize that because our slopes are different. So our intersection is that at week 2, they will share the same mass. So let's see where that is. So if that's 2, 3, 4, 5, 6, 7, 8, it'll be 8 pounds. They'll both be 8 pounds at week 2. So depending on the problem, you might be told to write the equation, or it could be given to you. So so for your homework today, I gave you yesterday 1 through 6. Today I'm going to give you, just need to make sure I give you an equal. I'll give you 19 through 23. Okay. And then 25 and 26. This is on page 338 and 339. Okay. Let me know if you have any questions. We'll go over this homework when we return in person on Tuesday. Hope you all have a great weekend. Again, let me know if you have any questions, and I will talk to you later. See ya.